I'm Dalan Zartman, Chief Operations Officer with the Energy Security Agency. We're proud to welcome you to the Lucid Emergency Response and Safety Series. This series of informational videos are designed to equip first and second responders with all the information that is needed to safely interact with Lucid vehicles in the case of an emergency. We're going to get started with an overview of the Lucid vehicle, identifying all of the key components and features that first and second responders need to be aware of. We will then jump into identification of the vehicle, energy management of the vehicle, safely approaching the vehicle, and we will culminate everything with the more advanced evolutions of extrication, suppression, submersion management, and recognition of thermal events. At the end of this series of videos, first and second responders with proper training and certification should be capable of utilizing this information to safely respond to and interact with Lucid vehicles in any emergency event. Let's begin with the high voltage power system that's within the Lucid vehicle. The Lucid vehicle is equipped with a high voltage battery pack of 900 volts, comprised of approximately 6,600 lithium-ion cylindrical cells. Those cells are encased in a module pack, and up to 22 module packs may be located within the battery pack. The battery pack comprises the entire floor pan of the vehicle from axle to axle and from rocker to rocker. The energized components within the battery pack have minimal allowances at the borders. There are no significant gaps between the edge of the module packs and the beginning of the rocker panels or the other borders or boundaries of the vehicle. All Lucid vehicles are equipped with a charging port that is located on the left side of the vehicle at the A-pillar and bulkhead junction. The charging port is a high voltage charging port that accepts both AC charging and fast DC charging. High voltage cables leave the charging port and are fed directly into the Wonder Box. The Lucid Wonder Box is an onboard charger that supports bi-directional energy operations. High voltage cabling then leaves the Wonder Box and provides energy to the high voltage battery pack. In the majority of Lucid vehicles, drive units are located with the front axle and the rear axle providing all-wheel drive. In some Lucid vehicles, you may only have a rear drive unit. The drive unit is comprised of a gearbox, an inverter, and the drive motor. The inverter controls the power flow for the drive unit. The gearbox and the drive motor work in unison to provide propulsion and management of the vehicle. High voltage capacitors are located throughout the Lucid vehicle within the high voltage system. Capacitors are located in the thermal system, the drive unit, and the high voltage battery pack, as well as the Wonder Box. The thermal management system for Lucid vehicles is also a high voltage system. It provides both heating and cooling to the passenger compartment as well as the high voltage battery pack. The thermal system is comprised of two separate fluid reservoirs or coolant reservoirs. It's also composed of a high voltage AC compressor. The compressor is located on the right side of the bulkhead, and the fluid reservoirs are located on the left and right side of the bulkhead. The heating unit for the thermal system is located within the flooring assembly directly under the pilot panel. The passenger compartment of the vehicle is equipped with a series of displays as well as some control features that first and second responders must be aware of to safely and properly interact with the Lucid vehicle. The display screens that are of primary attention and focus for first and second responders are the left screen within the glass cockpit, as well as the pilot panel, which is a screen that retracts from the center console. Both of these display screens are equipped with icons that are touchscreen based that first and second responders can interact with to open doors, close doors, as well as negotiate the position of the steering column. The seat controls within the vehicle are located on the seat and will allow first and second responders to manipulate the seat position. The gear selector on the right side of the steering column is a stalk that can be negotiated through drive, neutral, and reverse. Additionally, it has a parking button feature on the end of the stalk, which will engage the electric parking brake on the rear axle of the vehicle. For towing operations, Lucid vehicles are equipped with a tow eye that is located in the right trunk space in a storage compartment on the flooring area. The tow eye should be removed for towing operations from the stowage area and brought to the front of the vehicle. The lower grille on the front bumper assembly will have an opening with a rubber plug. The rubber plug should be removed and the tow eye should be threaded in a clockwise fashion and fully seated for towing operations. Lucid vehicles are also equipped with a low voltage operating system. This system is a 12-volt system comprised of a redundancy with two 12-volt batteries. These 12-volt batteries are AGM batteries, which is a form of lead-acid battery that is safer with better energy performance. These batteries are located in the right rear trunk space underneath a cosmetic panel, as well as underneath the center rear seat. To gain access to the rear battery, simply open up the trunk space and remove the cosmetic panels. The center battery, located under the center rear seat, requires a firm lifting of the lower seat cushion until the retention clips are released and then the battery is exposed. If first and second responders elect to isolate the low voltage batteries, both batteries should be isolated and the negative terminals on both batteries should be removed or cut. The low voltage system provides power to all the operations of the vehicle that are not covered by the high voltage system. This includes everything on the pilot panel and the display screens, movement of the seat and the steering console, as well as the door handles and all electromechanical latches within the vehicle. Without adequate 12-volt supply, none of these systems operate. An additional important feature within the vehicle that is dependent upon 12-volt power is the supplemental restraint system and lighting features of the vehicle. When considering relocating a Lucid vehicle without power, through lateral movement or vertical movement, it is important for first responders to understand the key factors that they must consider. The first being the overall vehicle weight. The approximate weight of a Lucid vehicle is 5,300 pounds. There are 4 approved vertical lifting points located on the corners near the rockers, under the A pillars and C pillars, 1 at each pillar position. Vertical movement or point loading in any location on the floor pan or the undercarriage of the vehicle can compromise the battery pack and cause mechanical or physical abuse to the batteries, resulting in potential thermal runaway. For lateral movement of the vehicle, the only approved mechanism is the tow eye with proper rigging applications. If the tow eye is not accessible and first and second responders must use other mechanisms to relocate the vehicle, the A pillar and the B pillar are the only approved pushing or hauling points. Additionally, proper synthetic slinging through approved applications within towing considerations should be applied. Lucid vehicles are equipped with a wide array of sensors designed to detect deceleration as well as impact. Those sensors will communicate with the supplemental restraint system to improve the safety and outcome for passengers within the vehicle. Supplemental restraint systems are comprised of the following items: air cushions or airbags, gas inflators for the air cushions or airbags, as well as seatbelt pretensioners. Seatbelt pretensioners are located at all 5 seat positions within the Lucid vehicle. Airbags located within the Lucid vehicle will deploy based on the location of impact and deceleration. In the case of a rear impact that is isolated with no additional front impact, no airbag deployment will occur. In the case of a front impact, all 4 airbags on the front of the vehicle will deploy. the supplemental knee restraint airbags, as well as the steering wheel airbag and the occupant dash airbag. In the case of a side impact, only the airbags on the side of the impact will deploy. There are airbags located in the outside seat area, as well as a side curtain airbag. In some markets, vehicles are also equipped with an interior side seat airbag for the driver of the vehicle. The side air curtain airbag is deployed through a gas inflator that is a high pressure cylinder located between the B pillar and the C pillar in the roof line of the vehicle. Under no circumstances should first responders apply pressure to that gas cylinder through the use of hydraulic cutters. Adding pressure to that cylinder will result in a BLEVE or a rupturing of that cylinder that could result in serious injury or death. If that area of the vehicle requires cutting or separation, first responders should only use reciprocating saws to perforate the cylinder as opposed to applying pressure to the cylinder. In the event of airbag deployment, Lucid vehicles are equipped with an integrated safety system. The integrated safety system is designed to react to the airbag deployment and put the vehicle into a safe state to facilitate better operations for first and second responders, as well as the passengers of the vehicle. When the airbags deploy, provided all systems are operational within the integrated safety system, the vehicle will go into park mode. The high voltage relay will be opened on the battery pack, isolating high voltage energy to the battery pack. The hazard lights will come on, and the door handles will extend from the vehicle, allowing access to the vehicle. When first and second responders arrive on scene, it is important that they can readily identify a Lucid vehicle. That can be done informally through the unique body style design, the unique lighting fixtures at the front and rear of the vehicle, as well as the flush door handle. More formal identification of the vehicle can be done through the recognition of badging. The Lucid logo will be located on the front hood area of the vehicle, as well as the rear deck lid area of the vehicle. On the rear of the vehicle, the Lucid logo will be located within the tail lamp assembly, unless that vehicle is in the Kingdom of Saudi Arabia market or the European market. In those two markets, the rear logo will be above the tail lamp assembly, located on the painted portion of the deck lid. Additionally, in the Kingdom of Saudi Arabian markets, you will notice an EV badge located in the sail glass panel on the rear doors on both sides of the vehicle. When first responders arrive on scene, it's imperative that from a distance, they conduct hazard recognition. The primary hazard that we want to be aware of is anything related to a thermal event or thermal runaway. Those events can be detected through our three senses: sight, smell, and sound. With sight, any visual representation of off-gassing or smoke should be considered related to a thermal event until proven otherwise. Lithium-ion batteries produce a unique odor. The odor is commonly described as cherry bubblegum. More specifically, it will smell like an electrical burning odor, influenced with a very sweet and fruity tone. If rescuers recognize that odor, they should assume that they are in the early stages of off-gassing and thermal event. Related to sound, any indications audibly of arcing, buzzing, popping, or hissing are all indications of a thermal event or thermal runaway. If any of those conditions are present, the immediate actions that should be responses to any of those indicators is that first responders should don full protective ensembles. That's full structural turnout gear, as well as SCBA breathing apparatus. If second responders recognize any of those early stages of event, then second responders should retreat from the vehicle a minimum of 75 feet and call 911 or contact emergency services. When first and second responders approach the vehicle, it is important they do so from a lateral position or from an angled position. Approaching the vehicle from the front or the rear could result in injury. It's important to remember that Lucid vehicles, although they emit a low audible tone when they are energized and in ready status, that tone may not be heard from a distance. If the occupant or the driver are still in the vehicle and the vehicle is in drive or reverse, that may not be known from the exterior presentation of the vehicle. If rescuers were to approach from the front or the rear, the driver could incidentally contact the accelerator and the vehicle could propel at a rapid rate of speed forward or backward and strike incoming rescuers. So always approach from the lateral position. As the approach gets closer, it's important to add a secondary level of initial stabilization. This is accomplished through the application of wheel chocks. Aggressive wheel chocks should be positioned in front of and behind the wheels to help minimize the potential for movement front or back. When the vehicle has been compromised and first and second responders are attempting to make access to the occupants in the interior of the vehicle, if the airbags have deployed and the 12-volt power is intact, then the handles will present themselves and the doors will be unlocked. Rescuers simply have to lift upwards on the handles, open the doors, and gain access to the interior of the vehicle. In the case that the system has malfunctioned or been so heavily compromised that it cannot operate properly, or in the case that 12-volt power has not been adequate, sufficient, or is lost, the handles will not present themselves. There is no way for first and second responders to provide electromechanical movement of those handles without engagement of the operator on the inside of the vehicle and 12-volt power. So first and second responders are left with two options to gain access to the vehicle without 12-volt power. Option one is to break glass. Upon breaking glass, responders can access the interior door latches. To open the doors on all four doors using the interior latches when there's been a loss of 12-volt power, it requires a two-stage toggling of the interior door latch. Stage one would require the first and second responders to move the door level all the way to the rear position and allow it to reset. Then engage the lever a second time and the door latch mechanism should release. If glass is not broken or the door latch fails to operate the disengagement of the latching mechanism, then first responders will have to engage extrication techniques to force the door into an open position. When interior access to the vehicle has been gained, first and second responders should locate the manufacturer's label located on the lower A pillar. This will give the first and second responders both the make, model, and year of the vehicle, allowing them to gain more detailed resources and information pertaining to the vehicle for their interaction. If 12-volt power is intact, first and second responders could maneuver the seat as well as the steering column through controls. The seat controls are located on the side portion of the lower seat. The steering controls are located within the pilot panel. By accessing the touchscreen icon, the column can be both telescoped as well as moved up and down to gain additional access to the victim. If 12-volt power is not intact or adequate, these control features will not be accessible. Manipulation of the steering column and steering ring will have to be accomplished through extrication techniques with proper tools and training. Manipulation of the seat should not be attempted under any circumstance. Movement of the lower seat pedestal can cause damage to the floor pan, resulting in pressure or mechanical and physical abuse to the battery pack, which could theoretically result in thermal runaway. Now that first and second responders have gained access to the interior of the vehicle, we want to work towards additional safety steps to manage the energy status of the vehicle. The first way to do that is to evaluate the display screens. If the glass cockpit screens or the pilot panel are illuminated, then we can ensure that 12-volt power is intact and is providing energy to those interactive screens. There will be a ready status indicator on the vehicle, and the vehicle may present the potential to go into gear and move forward or backwards. It's also important to understand some basic operating features of the Lucid vehicles so that we can know how to interact with that scenario. For example, when the driver's door is opened on the Lucid vehicle, that driver door opening will have an automated response that puts the vehicle into park mode. However, if one of the other doors are opened and accessed by first and second responders, that automated feature does not apply. In that scenario, it's imperative that first and second responders push the park button on the drive mode selector stalk to make sure that the vehicle is in park. We additionally need to remove sources of input that energize the vehicle and allow authorized entrants to operate the vehicles. The two remote tools that owners of the vehicle can use are cell phones and key fobs. These are their primary choices and allow full operation of the vehicle. The third component is the NFC card. The NFC card is not remote, but direct access to gain control of operating systems within the vehicle. When first and second responders are inside the vehicle, to ensure that the vehicle powers down and does not have subsequent or unintentional operating sequences occur, those three items should be removed from the vehicle a minimum of 30 feet. Now that objects have been removed from the vehicle, in the case of a vehicle that has airbag deployment or significant damage to the vehicle or electrical failure of the vehicle, first responders should initiate secondary shutdown to further isolate the energy within the vehicle. That will require access initially to the first responder cut loop. The first responder cut loop will be located on the left side of the vehicle near the bulkhead. It will be positioned under a cosmetic panel. The cosmetic panel runs from the left side of the vehicle to the right side of the vehicle. The panel can be removed by simply pulling up on the top of the panel until all the retaining clips are released. The panel can then be displaced. The first responder cut loop is identified as a red cable with an identifying label on it that shows a fireman's helmet icon with a set of cutters as an icon. Responders will have two choices. They can either cut the cable in two positions on each side of the label, or they can remove the plug. It is encouraged to ensure that additional responders within the chain of custody don't incidentally reconnect the plug. That significantly damaged vehicles should have the cut loop cut. If the damage is minor to moderate and first responders elect to isolate the energy using the first responder cut loop, that would be a scenario where first responders could disconnect the plug. It is important to understand the purpose of the first responder cut loop. The first responder cut loop feeds a relay in the high voltage battery pack. And when that cut loop is cut or disconnected, it opens those relays, isolating the high voltage energy to the battery pack. Once the first responder cut loop has been cut or disconnected, it will also isolate the energy of the 12-volt batteries. In the case or scenario where the first responder cut loop is not accessible or may not be operating properly due to significant damage to the vehicle, first responders can access the 12-volt batteries to also initiate energy-based shutdown. The 12-volt batteries, again, are located under the center portion of the rear seat and in the rear cargo space. Once the 12-volt batteries have been accessed, first responders simply need to cut or remove the negative cables going to the batteries. This will isolate the low voltage energy to the 12-volt systems. Isolating or disconnecting just one 12-volt battery is not adequate. If 12-volt battery isolation is the course of action that is pursued, first responders should make sure that they disconnect both 12-volt batteries. In this module, we're going to be discussing firefighting operations. In order to do that, we must understand foundationally what lithium-ion battery fires are. They revolve around a term that we call thermal runaway. To understand thermal runaway, we need to understand a little bit about lithium-ion battery chemistry, design, and the events that occur when they initiate thermal runaway and ultimately fire events. Lithium-ion cells used in the Lucid vehicle are cylindrical cells. These are cylinders or cases with two end caps on each end. Inside of the cylinder, we have an anode, a cathode, a separator, and electrolyte solvent inside of the system. That electrolyte gel, paste, or liquid with organic solvents in it is inherently flammable. When that battery cell is abused, thermally, physically, or electrically, any one of those forms of abuse can create short circuits and heat within that battery cell. As short circuits and heat affect the electrolyte gel, paste, or liquid within the cylinder, that electrolyte begins to boil and build vapor pressure. It eventually hits a point where the end caps rupture. Ignition temperature is present, and the gases that are released are both toxic and flammable. With proper ignition temperature, those pressurized gases will ignite and they will produce a pressurized fire stream. In the Lucid vehicle, multiple module packs carry lots of individual cells. As the cells begin to off-gas and go into thermal runaway, they will affect other neighboring cells, which is called propagation. As that gas develops, that gas will leave a module pack, will make its way through the battery pack, and will find the engineered vent pathways within the battery pack enclosure. Those vent pathways are located on the corners of the rear of the battery pack and the corners of the front of the battery pack. This will produce pressurized gas releases that will release near the A pillars and the C pillars at trajectories or angles designed to allow occupants to egress the vehicle without being in direct line of contact with the flame. When first responders are confronted with an impending thermal event or active fire, they must make quick tactical decisions. There are two basic choices in addressing this hazard level. The first choice is to allow the vehicle and the fuel load to freely burn. There are benefits to choosing this course of action. When lithium-ion batteries freely burn and have active fire, the vast majority of the toxic and flammable gases are being consumed and combusted within the fire. That eliminates a large percentage of the atmospheric hazards that are produced during the off-gassing phase. Conversely, if first responders elect to apply suppression agents to the battery and attempt to cool and extinguish, it'll be very difficult to gain access to the primary fuel source. It may also just intermittently slow down the burning process, producing more atmospheric hazards and providing more environmental challenges for managing the event. Let's go into a little bit deeper detail about those two options. If option one is selected, first responders should identify all possible combustible and flammable exposures. They should then apply cooling streams and protective streams through a variety of applications using remote monitors or handheld nozzles to apply water to all those components. That should prevent the fire spread from growing to adjacent objects or combustibles. If option two is selected, then first responders must understand the end objective. The end objective is to apply cooling material to the interior of the battery packs and battery modules to actively cool the lithium-ion battery cells. The most effective agent that can be applied to lithium-ion batteries for cooling is water. No other suppression agents are authorized unless used in a short-term application and only in the absence of water. If other agents are selected, The only other authorized agents are multi-class extinguishing agents. Foams can produce conductivity, and all other agents that produce encapsulating characteristics can prevent the battery from freely burning, but they will not stop thermal runaway or actively cool the lithium-ion battery cells. So the resulting action or consequence is a prolific buildup of toxic and flammable gases that are captured within the encapsulating agents that eventually hit a heat temperature where they breach the encapsulating agents, are released in a fuel-rich gas cloud, lean out as they are introducing and inducting fresh air, and then produce explosivity. So the application of agents other than water can result in an explosive environment as opposed to a controlled burning characteristic with a flammable environment. In order to apply water to the battery pack in a manner that will actually cool the lithium-ion battery cells, the vehicle must be relocated to allow streams and access through the vent points or through breach points in the vehicle when significant collisions have occurred to actually fill the battery enclosure chamber with water. That may require extrication applications using lifting and stabilizing techniques to reposition the vehicle and position remote hand lines or not monitors to apply that water. Copious amounts of water may be required if indirect cooling is applied, sustained exposure protection routes, or limited or restricted access to the interior battery pack. First responders should have adequate water flow plans with tanker shuttle operations and adequate volumes of water to appropriately attack these vehicle fires. If adequate access is available through a breach in the floor pan or through compromised vent points to allow proper flow of water to the interior of the battery enclosure, thermal imaging cameras and 4 gas meters should be used in conjunction with firefighting operations to validate the effectiveness of suppression and ultimately extinguishment. Battery temperatures that are above 200 degrees F are not in a safe state and will most likely reignite or re-engage into thermal runaway and propagation. With the application of water, the smoke or gas indication or characteristics of lithium-ion battery fires typically remain very light colored or white in nature. This is often misperceived or misunderstood as steam as a result of cooling the batteries. To differentiate between steam and lithium-ion gas production, 4 gas meters should be placed into the gas clouds to evaluate for the presence of CO. CO components will not be present in the production of steam. Once the batteries have been actively cooled, CO values are not present in the 4 gas meters, then the thermal imaging cameras should be relied on and the batteries should maintain a temperature of 200 degrees F and continually reducing before the vehicle is considered to be in a relatively safe state. After 45 minutes to 1 hour of sustained temperatures below 200 degrees Fahrenheit, it can be assumed that the battery pack will not readily reignite or go back into thermal runaway without movement of the vehicle that would potentially displace battery cells and cause secondary short circuits. It's also very important for first responders to understand that if they have engaged in suppression operations on the battery pack, they may cool the battery pack and isolate the thermal event, but there still may remain a large quantity of intact, highly energized battery modules or battery cells that with movement or with irritation through electrical abuse, thermal abuse, or mechanical abuse may initiate a secondary event of thermal runaway and propagation. If suppression actions have been initiated and battery temperatures have fallen below 200 degrees Fahrenheit for 45 minutes to 1 hour, that does not guarantee that the entire battery pack is safe. The cooling operation could have knocked out the thermal event in a portion of cells or in an isolated module, but subsequent modules within the battery pack, as well as isolated cells, may have not been engaged in the thermal event, may have a high or full state of charge, and may still present a significant hazard of secondary ignition or thermal runaway. Statistically, these secondary events occur most commonly when the vehicle is moved, relocated, or transitioned. Any of those movements can move or shift the battery cells or the systems within the high voltage battery pack, resulting in additional short circuits, which cause the heating event to reoccur, resulting in secondary thermal runaway and propagation. After the waiting period has been concluded and the vehicle is prepared for transport via tow truck, as well as cleanup of the environment, it's very important that first responders evaluate the area for the displacement or loss of cylindrical battery cells. In the case of fire, the floor pan, the vent points, may melt and expand and allow cylindrical cells to displace from the vehicle. Cylindrical cells can become projectiles as the enclosure becomes compromised through fire damage or through significant collision. The cylindrical cells can burst open at the end caps with a pressurized release of gas, forcing them out of the enclosure similar to a small rocket. As they come to rest, sometimes they will take intact cells with them that have not been compromised or vented yet. So as first and second responders evaluate the environment and the scene surrounding the vehicle, make sure that all individual cells that may be displaced from the vehicle are addressed. Displaced cells should be evaluated and placed into two different categories for two different handling operations. First responders or hazmat specialists should be the only individuals interacting with these battery cells. The first assessment tool should be the thermal imaging camera. The field of battery cells as they lay about should be evaluated for any hot battery cells. Hot battery cells should be extracted and removed or isolated from the other battery cells. This will require full protective ensembles to be worn while interacting with the cells. Secondary assessment of the battery cells will involve the evaluation of vent caps, whether or not the cells have discharged and vented, or whether they have been displaced and are still intact without any venting. Intact cells may still have a full state of charge on them and are awaiting presentation of thermal runaway. To properly handle the intact cells that appear not to be vented, non-conductive buckets should be filled with water. Those energized cells should be placed into that water. Those energized cells will short circuit and will develop a thermal runaway event within the water. But the cooling water will cool the cells so quickly that it will manage the event, making the event relatively safe. As those cells are added to the bucket and then prepared for transport, that bucket should be capped with a cap that has a vent point on it so that gases do not develop and build up within that container. Cells that have been populated within that isolation container are recommended to be stored for a period of 14 days as a minimum. Specialized cleanup contractors and transportation contractors should be contacted by first and second responders, ensuring that movement of those batteries are done in compliance with all standards applicable to hazardous waste. All other battery cells that appear to be vented and displaced will not have a stored state of energy on them and can be collected and placed into a dry, non-conductive basin. Those batteries should then also be transported back to an area, and integrated management of those should be conducted with a hazmat cleanup company or an environmental specialist group. When conducting firefighting operations, first responders should first identify which side of the vehicle is producing the off-gassing or fire plume. Upon recognition and identification of the involved side, an initial attack line should be deployed and water should be applied to that vent point to direct both gas and fire away from other first responders as they access the vehicle. The second objective is to apply wheel chocks that will adequately resist lateral movement of the vehicle on the non-involved side of the vehicle. Creating a pivot point on that side of the vehicle will allow responders to lift the involved side of the vehicle where the vent point has already breached and apply cooling applications through the vent point to adequately cool the lithium-ion battery cells within the overall battery pack. It's important to remember this key point so that the opening is at the elevated position of the vehicle and the water can fill the remaining compartment. If the reverse is applied, then the breach point or vent point on the battery pack will be on the pivot side or the low side of the vehicle, and all cooling efforts will be lost. As soon as the wheel chocks are applied, first responders will approach the involved side of the vehicle behind the water application of the primary attack line. The primary attack line will manipulate the nozzle between wide fog approaches and straight stream approaches to properly guide and direct fire and gas away from the first responders. There are three primary objectives on the involved side of the vehicle. 2 cribbing columns should be created to properly support, stabilize, and capture the progress of the lifting evolution. While those 2 cribbing columns are being built and oriented at the A pillar and the C pillar position, the other first responder will enter the equation with a hydraulic spreader. The spreader should be positioned at the balance point under the rocker panel of the vehicle. The balance point is identified as approximately the midpoint of the front door. Ensure that your spreader tips are not positioned too deep underneath the vehicle, as the tips may make contact with the battery pack and induce further mechanical abuse or physical abuse to the batteries and create a secondary ignition point or short-circuiting area. As soon as the tips are in the proper position under the rocker panel, the first responder with the spreader will initiate the lifting action of the vehicle, and the 2 first responders on the cribbing columns will advance their columns to capture the progress of the lift. When maximal reach has been achieved with the spreader, then the spreader will gently bring the vehicle back down to rest on the cribbing columns, and the 3 first responders will retreat from the involved side of the vehicle, retreating ahead of the nozzle man. The nozzle man will continue to apply water flow to the primary hazards and withdraw and reorient so that he can now direct streams at the battery pack vent point and initiate the cooling process for the lithium-ion batteries. As we prepare to discuss extrication techniques, it's important that first responders have a full awareness and understanding of the locations of hazards that may interact with their extrication sequences. Every component that we've reviewed to this point within the vehicle are points of consideration. Let's review some of those. The first one is the SRS components. 2 primary considerations: high pressure gas inflators and supplemental restraint systems involving seatbelt pretensioners. Additional points of concern would be any component of the high voltage system. So any portion of the drive unit, the high voltage cables, or the high voltage battery pack should all be no cut or no interaction zones. One of the most important ones to discuss is the charging port and the high voltage cables coming from the charging port. This is in an area of the vehicle where, as extrication practitioners, we often engage. With all Lucid vehicles in all markets, the charging port is always located on the left side A-pillar and bulkhead joint. This area should be avoided with crushing, cutting, or manipulation. This will directly impact all dash movements that are made on this side of the vehicle. Fortunately, Lucid has created a design that is very friendly for extrication, in that the capacitors and most of the high voltage components are all located on the center axis of the vehicle. This allows the sidewalls of the vehicle to be largely engaged without significant concern of impact or engagement with high voltage components. When performing any lifting or stabilization techniques, any point loads anywhere on the floor pan, within the undercarriage or within the interior compartment of the vehicle should be avoided. Any of those point loads with extrication tools, airbags, or any lifting applications can cause mechanical or physical abuse to the battery packs, which can result in short-circuiting and thermal events. Let's walk through some specific applications, keying in on the identifiers that we need to be aware of or avoid. If 12-volt power is not available and first responders cannot initiate the touch icon to open the front hood, then that process should be completed with extrication tools. First responders have a variety of options. One option is to access the manual release cables within each wheel well on the left side and the right side of the vehicle in the front of the wheels. First responders will locate two pull cables. Those pull cables are two-stage releases. So two first responders can locate at each pull cable, initiate stage 1, and then initiate stage 2. This will override the two electromechanical switches and collections at the front of the hood and allow the hood to be released. In significant compromise, damage, or pressure stressing of the hood, the release cables may not operate. If first responders still elect to make the primary latches their focal point, then they can use hydraulic spreaders to the front of the hood and expose the two latch mechanisms and then cut the two U-bolts with hydraulic cutters. If first responders elect to attack the hinge side of the hood, this would be the more preferred method because the only primary target within the hood assembly would be the first responder's cut loop. The first responder's cut loop is located on the left side of the vehicle, and first responders could simply advance hydraulic spreaders down the windshield pathway and load the left corner of the hood. As the hood is elevated and the hinge is exposed, a hydraulic cutter can then cut the hinge, thus allowing the hood strut to extend and elevate the hood, and now the first responders would have full access to the first responder cut loop. If they desire to fully remove the hood, then the same operation could be conducted on the opposing hinge, and then the latches could be released, or the hood could be manually folded forward. To release or relieve the hood struts should only be cut or compromised when they are fully extended, and all first responders should understand that there is an inherent low-level risk associated with cutting those cylinders. It is a better practice to remove the connectors at the end of the hood struts so that they can be released freely and allow the hood to be displaced. When gaining access through the doors of Lucid vehicles, first responders have two choices. They can work hinge to latch, or they can work latch to hinge. That situation will be largely dependent upon the damage to the vehicle and how the doors present. First responders should always choose the easiest possible access point to make the most efficient maneuvers on the door. If the door does not release the latching mechanism upon movement of the interior door handle, then first responders should initiate extrication sequences. In order to work hinge to latch, a purchase point must be established near the hinges, and a purchase point is separation of the door skin from the fender skin. This will allow a gap to apply proper tool placement within the hinge assembly. On the left side of the vehicle, when working in close proximity to the charging port, movements that would directly affect the fender skin are highly discouraged. The primary choice would be to apply hydraulic spreaders into the window gap and spread. This will draw the door and the energy of the door out and away from the victim and produce a gap on the A-pillar line. This would then allow the rescuers to relocate their spreaders to the top hinge joint and begin to gap that joint. First responders would have two choices from that point moving forward as to whether they elect to cut the hinges or spread the hinges. They should also remember the tension mechanism in the center point of the door that will also need to be cut or spread. During all of these movements, it is encouraged that first responders resist excessive movement of the door. If the latch has been compressed and the initial movements of the door handle did not release the door, that application may still be effective and allow the latch to release when the tension is taken off of the latch mechanism. So by reducing the amount of movement on the hinge side of the door and releasing the tension and compression, responders can often then reach back to the inside of the vehicle and attempt the two-stage movement of the lever again, thus releasing the door and allowing it to come away from the vehicle. If the second attempt with the door lever fails, then first responders will relocate to the latch side of the door and begin to gap the door with hydraulic spreaders until they can get into a position where they can apply what we would refer to as a hard touch. A hard touch would be positioning the spreader tips against a firm contact point on the B-pillar and against the housing or the bolt patterns on the latching mechanism within the door assembly. All touches and placements should be focused towards the interior portion of the door and not the lateral edges of the door where the outer door skin and the inner door skin are adhered with epoxies or adhesives. Upon pressure and separation, the latch mechanism should give up, and then first responders are free to remove the front door. Once the door is removed, if in evaluating the patient we identify that the dash has intruded in and is entrapping the patient, then we must perform dash techniques. These are very specific and vary depending on which side of the Lucid vehicle you are operating on. If you are operating on the left side of the vehicle, the charging port and the high voltage cables are of extreme concern and should be areas of caution for first responders. The primary dash displacement technique that is recommended for the left side of the vehicle is a no relief cut or blind dash displacement using a spreader that is positioned on the weld seam of the rocker with the lower tip and the upper tip progressing up through the dash assembly and contacting the structural reinforcement system that supports the dash assembly, transferring from A pillar to A pillar. When applying this technique, first responders should apply additional stabilization or cribbing under the rocker point of contact, and careful attention should be paid to make sure that the lower tip does not initiate crushing or displacement of the rocker that would potentially bend or compromise that portion of the floor pan. If the rocker becomes crushed or displaced to the point that it starts to malform the battery enclosure or floor pan, thermal runaway could be induced through mechanical abuse or physical abuse to the battery pack. The only approved posting point for this technique or stabilizing point for the lower tip is the weld seam of the rocker. Under no circumstances can the lower spreader tip be pushed into the vehicle and loaded directly onto the floor pan. Special attention should be paid to ensure that as the spreader reaches wide angle openings in the attempt to displace the dash, that the lower tip, while losing surface contact with the weld seam, does not slip off of the contact point and in a sudden and impactful manner come into contact with the interior floor pan and battery pack enclosure. To improve access to the occupants within the vehicle, it is recommended that both doors be removed and then the B-pillar be dealt with as an independent object. A variety of modern-day techniques where the B-post is leveraged with a single cut and then displaced or moved with spreaders or rams can be attempted, but first responders should remember that the kinetic energy in the B-pillar is incredibly strong and resistant to movement, and due to the lack of stability at contact points for tools, the B-pillar can snap back violently to its initial point, and the tools can displace violently from that maneuver if the contact points aren't reliable. So first responders are encouraged to consider those courses of action with a risk-benefit analysis. The safest way to approach the B-pillar is to simply remove both doors and then make cuts on the B-pillar. It's also important that the cuts on the B-pillar are made strategically. The first cut that should be made on the B-pillar is the lower cut on the B-pillar. If your hydraulic cutters do not have a wide enough opening to drop down towards the lower portion of the B-pillar, then crushes can be accomplished sequentially with the hydraulic cutters where full cuts aren't made but compression is made, reducing the diameter of the material and then opening up and allowing the blades to drop down. Also ensure that the blades do not go so low on the B-pillar that they're going to contact or interact with the seat belt pretensioner. This location should be approximately 6 to 7 inches above the rocker panel location within the B-pillar assembly to ensure that the pretensioner is not contacted. Once the lower B-post is cut, then the cutter should migrate up to the top of the B-post. It is a good practice to deadhead the B-pillar. Deadheading is a term that refers to applying a pressure-loaded weight to the B-post so that the B-post energy and movement can be controlled when the freeing cut is initiated. Remember the kinetic energy built into the B-pillar and the violent reaction of the tools. When the B-pillar is now a freestanding segment and we complete the top cut, the B-pillar will have a tendency to want to project away from that cut, meaning the B-pillar is going to drive down. As the cutter initiates the uppercut on the B-post, the spreader can be engaged on the lower B-post with a crushing action. Once it has a firm grip of the lower B-post, the secondary rescuer can leverage the lower B-post away from the vehicle and the occupant while the uppercut is being initiated. That allows that cut completion to result in the B-pillar driving down to the ground and safely moving away from the victim, as opposed to becoming an uncontrolled projectile. If first responders encounter a need to remove the roof of the vehicle, it's important to note that not all Lucid vehicles are equipped with glass roofs. The glass embedded in the roof structure of the Lucid vehicle is incredibly high-strength glass. When removing the roof segment, it is recommended that rescuers cut all 4 upper pillars in proximity to the roof line or at the lower locations in proximity to the dash assembly and to the rear deck lid area, and then simply remove the roof from the equation. There are other alternatives for roof spins and other techniques that are used that are all acceptable applications when done safely and properly. It is a rare occurrence for a Lucid vehicle to come to rest on its side or on its top due to the low center of gravity of the vehicle. But if a Lucid vehicle does end up on its side or on its top, first responders should be conscientious about contact points as well as lifting points for stabilization and lifting. If applying struts to the vehicle, on the roof side of the vehicle, normal contact points are acceptable. Junctions between the A-pillar and dash assemblies, junctions between the C-pillar and the deck lid. Make sure that your struts are applied to positive contact or anchor points, and use appropriate anchors for your hobble straps or ratchet straps. On the undercarriage side of the vehicle in a side resting position, this is where first responders must be attentive to ensure that struts aren't point loaded or positioned in areas where the traction battery pack is located. There's a very minimal gap between the edge of the battery modules and the initiation of the rocker seam, so sidewall connections within the framework of the axles are not encouraged. First responders should consider using capture points at the very front or the very rear of the vehicle on the sidewalls, or adjusting to make connections to control arms or what traditionally would be considered moving components. Tension back ties and other tensioning elements can be used to apply full tension buttress concepts to the vehicle for proper stabilization in side presentations. For vehicles that are inverted, acceptable lifting points on the roofline can still be identified as the corners of the C-pillars or the roof rails for airbag applications or for spreader applications. Additional airbag components can be positioned under the B-pillars as well if enough gap is exposed in those regions. Struts can be positioned along the quarter panel walls of the vehicle, and basket rigging or chain applications across the deck lid are all acceptable applications. If a victim becomes entrapped under the vehicle in an all four-wheel right side up presentation, we should revert back to the original designed or engineered lifting points on the vehicle and focus on any one or two of those 4 points of contact in close proximity to the rocker assembly under the A-pillars and C-pillars. During emergencies that occur while active charging is taking place, first responders should make it a focal point to disrupt the connection between the vehicle and the charging system. Many charging systems are equipped with a variety of shutoffs, from e-stops to breaker controls. But in the unique nature of the Lucid vehicle, containing the Wonder Box with bidirectional energy capabilities, the primary focus should be the vehicle itself. First responders can remove the charger handle manually by depressing the detent button on the top of the charger handle and pulling in a reverse motion. If collision has occurred that has damaged that area and the standard detent button does not release the charger, then the hood can be accessed in the variety of ways that we've discussed to this point, and first responders can access the secondary manual release, which is a toggle that lifts upward on the fender rail directly above the charger port. First responders should always assume that the vehicle is energized during charging operations and that the cable transferring energy to or from the vehicle is energized. There is a light indicator on the charge port that may give additional information about the charge status of the vehicle. White lights, green lights, and red lights. A white light within the charging port indicates a ready status. A flashing green light indicates an active charging status. A solid green light will indicate fully charged, and a red light will indicate that a problem has occurred in the charging sequence. First responders can use that additional information to help ascertain what is taking place with the vehicle, but should never assume that energy is not present just because of a lack of light indicators. If a Lucid vehicle has been submerged or exposed to high volumes of water for an extended period of time, there is a high likelihood that the battery pack has experienced encroachment with water. As that water makes its way into the battery pack, it can create widespread short circuits that will result in thermal runaway. There are some important concepts for first responders and second responders to consider. If first and second responders arrive on scene and the vehicle is still actively submerged, it is a strong possibility that the vehicle is developing thermal runaway while submerged. A risk-benefit analysis should be conducted to determine whether or not it is safe to put divers or rescuers into the water to make rigging connections to the vehicle. In these applications, indications of bubbling on the surface of the water, CO levels at the surface of the water, or any indications of smoke or gas coming off the surface of the water should be no-go scenarios where rescuers are not committed into the water source. In no way, shape, or form can the Lucid vehicle energize the body of water through the high voltage system. Rescuers should still follow normal precautions to avoid direct contact with high voltage components, but the remaining body of the vehicle and engagement with the body of water do not pose energy potentials for threats or hazards. If the water appears safe, no bubbling is present, no off-gassing is present, and no smoke or gas is present, Then first responders can commit resources to rig the vehicle. In the case of submersion, it is recommended that synthetic straps are wrapped around both A pillars or both B pillars. Then the towing provider or second responder will use proper techniques and proper load calculations to remove that vehicle from the body of water. Upon removal from the water, first responders should prepare for a thermal event. That vehicle should not be moved once it comes to rest on dry ground for a minimum of 45 minutes to 1 hour. During that resting and evaluation period, first responders should use the techniques we've discussed with 4 gas meters and thermal imaging cameras to properly assess the thermal presence and condition of the battery pack. Additionally, the vent points should be identified for the front or aft drainage points of the battery pack, and the vehicle should be lifted slightly to facilitate draining of water that may have incurred or encroached the battery pack. At the conclusion of the 45-minute to 1 hour waiting period, provided thermal temperatures do not exceed 200 degrees F, and there are no hot spots evident, no CO production, and no sights, smells, or sounds, then the vehicle can be safely loaded onto the transport carrier. It is also strongly recommended that during transport from scene to storage, that the vehicle is escorted or followed by a fire suppression capability apparatus, so that if an event occurs during movement or during transport, the transport vehicle could pull over to the side of the road, offload the vehicle, and first responders can engage the problem appropriately. For all Lucid vehicles that have encountered any kind of compromise involving mechanical abuse, electrical abuse, or thermal abuse, these vehicles should be isolated in a storage facility, much like the individual battery packs. Per SAE J2990 and echoed sentiments through NTSB, vehicles should be isolated 50 feet in all directions from all combustibles or placed in a perimeter barrier that allows 3-sided protection of the vehicle, above the height of the vehicle, enough width for the vehicle to have both doors opened or both windows opened so that the passenger compartment can freely vent, and enough depth of barrier that the vehicle is fully enclosed within that space. These barrier isolations should not be interior setups. They should all be outdoors with free ventilation. Special cautions are addressed towards first responders about applying copious water to these vehicles should they catch on fire. It's important for first and second responders to remember that as the water interacts with the vehicle, they can produce contaminated water, and this contaminated water can compromise storage sites. So the best tactical option in scenarios where vehicles are located in barrier isolation is to allow the vehicles to freely burn, reducing atmospheric and environmental hazards. On behalf of Lucid and the Energy Security Agency, we want to thank you for joining us for this informational training series. There are additional resources for first and second responders to gain, to study, and to reference when they interact with Lucid vehicles. www.energysecurityagency.com contains ERGs and QRGs for all EVs, but particularly Lucid vehicles. Additionally, the ESA provides a 24/7 contact center to provide real-time guidance to first and second responders in the field when they are interacting with electric vehicles. The contact number for the ESA call center is 855-ESA-SAFE. 855-ESA-SAFE. Full provisional training courses are available through a variety of mechanisms to make sure that first and second responders are equipped, well-trained, certified, and prepared to respond to these events. Lucid is committed to leading the way in enhancing the safety of first and second responders as they interact with Lucid vehicles. They're executing that mission and commitment through the design of their vehicles, the research that they put into their vehicles, and information and resources such as this series. The Energy Security Agency is proud to be a collaborative member of this process and grateful for the opportunity to engage with Lucid. Thank you for taking the time and energy to commit to the safety of yourself, your crew, your organization, and the individuals who own and operate Lucid vehicles. Stay safe.